Okay, I just brought this BITT transformer out and I'm testing it. The latest one with the air gap just isn't working out very well. And so I brought this one that I built a couple months ago. And it has laminate steel hand-cut shunt bars. And it's a solid three-phase transformer. It's not made from a line reactor. And it's showing 5 times more output than input. And I'll try to be quick about this so don't bore everybody, but I'll show you how I do this. And the power factor is important for it to be 90 degrees, near 90 degrees, and I actually have this at 100 degrees now. And I have a 1 ohm shunt up here for the current shunt for the scope, and I have it hooked up correctly. The tip goes to here, and then I have a 3.73 cap in series, and then it goes to the primary, one of the leads of the primary. The other lead to the primary goes to the straight to the other AC line, and that's where the voltage probe goes. Okay, and I don't have these reversed. These are correct. And I have the cap in between the shunt, current shunt, and the primary. So I don't have that wrong either. So everything looks good. And I might as well tell you what the phase shift is. One cycle, AC cycle, is 12.2 spaces, so 360 divided by that's 29.5. And the phase shift is 3.4 spaces, so 3.4 times 29.5 is 100.3. So let's look at that on this. This is the scope. My camera is kind of slow, so it doesn't catch it, but I put this onto a computer screen to really look at it good. So let's look at it on the screen. Meanwhile, we're making 8.73 volts across the 39.9 ohm resistor. That's the output. 8.73 into 3 across 39.9 ohm resistor. That's the output. The output, so the output is this. Only 1.9 watts. The input, however, is 0.373, which is 5 times less. And that is because of the phase shift of 100 degrees. And actually what I did is when it's over 90 degrees, it's actually returning power to the grid. And let's not worry about that. Let's just say it's 89. Let's go way conservative. Let's say it's 89 degree phase shift, even though it's actually 100. And that'll give you a power factor of 0.017. The VA is 21.96 if you just look at the amps and the volts. And I'll go through this quick. I know it's boring, but I'm in the 0.1 square division on my scope. Okay, So 0.1 volt square division. You divide by 5 because there's 5 little spaces within each square division. That's 0.02 volts per space. It's 26 spaces peak to peak. That gives you 0.52. You divide by 2, that's 0.26 times 0.707 to give you 0.18 volt RMS. I have a 1 ohm shunt resistor, so 0.18 divided by 1 is 0.18 amps times 122 volts input, and that gives you the volts times amps, 21.96. And that is not watts, because you need to know the phase shift. And the phase shift is 100 degrees, but I'm saying it's 89 degrees, just to give a number above the table, let's call it. So 0.373 watts. Here's the 26 volts peak to peak. Let's go look at the computer screen to confirm all this. Okay. Here's the phase shift. And if you do one cycle, like from here to, from here to here, comes to 12.2. I'm going to blow this up a little bit so you can really look at it. See, I'm not lying. Okay. I'm saying that phase shift is 3.4 spaces. And here it is again over here. Where is it? Right here. So it's not quite centered on that line. It's a bit to the left. And it's not right in the middle of that one. So it's, I'd say it's 3.4, a little bit less than 3.5. That's the phase angle. How many spaces? And it's 12.2 spaces for the, like from here to here. That's one AC cycle, so that's 360 degrees. Here it is again. So, I'm figuring the phase angle from the scope. Also, I'm figuring the amp draw from the scope. So, sorry, I left it on the camera. Anyway, so let's go again. It's a from the primary to the shunt. It has a single series AC cap 3.73. Now I want to show you one thing here. Let's say you go with a 10 instead of a 3. see the phase shift and everything and the peak to peaks. Just a minute. Okay, now I put a 10 instead of a 3.373. Now look, there's a lot more power coming out. It used to be only 8.7 volts. Now it's 32, just going with a 10 there. But look, it's really trashed. Look at how much more amps it draws. I'm still in 0.1 square division. I have to move the amps way over to 0.5 just to see it on the scope. So it's made a tremendous amount more amps. And look at the phase shift now. It's trashed the phase shift. It's only about 2.5 spaces or so, maybe 2. So it doesn't have that extreme power factor. It's not 90 degrees. Okay, and I'm going to put a 5 cap in series. Okay, so I put a 5 UF cap now in series instead of the 3.73 or the 10. And I used to have 8.73, so I have more power out by raising the UF. But the amps now is 40 spaces peak to peak. Well, it used to be 26, so it raises the amps a lot more. However, looks like the phase shift is about 3, so it dropped about half a space in phase shift. This is probably still around 90 degrees. So let's do one more cap. I'm showing you what the difference in AC caps makes. The series cap from the primary to the current shunt. Okay, 1 second. Okay, this is a 2 UF cap. And you see the phase shift is quite funny looking now for the current. But it's dropped the overall amps from 10 UF, it was 40 spaces. Now it's only say 18 or 17 spaces. So this really cuts the amp draw by going with a 2. But look, it really cuts the power output. It used to be double this. So it looks like a 2 UF is no good, especially with this funny looking sine wave for the current. So let's go back to a 3.73 like I did in the tests. Okay, now we're back to 3.73. And this is what all these figures are for. Okay, so I guess that's it. Thanks for watching.